pleasure. Thanks, Lorenzo.
Thank you, Alex. Welcome to our talk. My name is Lorenzo Bettini. I work as a professor at the University of Florence, working on programming languages. And this is a joint work with Vincenzo Caselli and Francesco Guidieri from RCP Vision, an Italian company located in Florence working on Eclipse technology. And we are all committers of EMF Parsley, and today I'm going to present a kind of experience report on how we tested and analyzed code quality for our Eclipse project, EMF Parsley. So EMF Parsley, in a nutshell, is an Eclipse project that aims at quickly developing applications based on EMF models. It's completely and easily customizable. It's based on declarative customizations. It provides an Xtext DSL to make all these customizations even easier. It supports all the EMF persistencies, and it also supports RAP. RAP is the Eclipse remote application platform that allows you to bring your RCP application to the web. So EMF Parsley provides some reusable components like trees, forms, dialogues, editors, or combinations of them for your EMF model. And we also provide some project wizards to get started. So under the hood, EMF Parsley delegates to EMF Edit, but everything is completely customizable. But we don't use extension points for customizations. We use dependency injection with Google Juice. We also provide, as I said, a DSL based on Xtext, and so it provides rich IDE tooling, complete interoperability with Java and its type system. It means that you can access all the Java types in your class path. And we are code generation oriented, so we are not reflective. And that means that you can easily debug everything with Parsley. So now I'm going to give a very quick demo. If you're interested in Parsley, tomorrow there will be a demo, a complete talk on Parsley. So now I'm just giving a demo to give an idea what Parsley does. So here I already have an Eclipse with Parsley. As I said, we provide project wizards to get started. So you can create a new Parsley DSL, you give it a name. You can choose if your project must be already ready for RAP. And we also provide some templates to get started. So you can start with a table, with a tree, with a combination. I'll just select one just to show you how a Parsley project looks like. So we start with the DSL, an Xtext DSL. So of course you have all the nice content-assist things. You can also jump to Java types. So this is a Java class. You can jump to it. We press save. We generate everything. We generate Java classes here in a separate source folder. We also, this is the way we define a view part extension point in Parsley, and we generate the plugin XML for you. Actually, we merge the plugin XML for you. But now I'm going to use some predefined example that ship with Parsley, so you can import new Parsley examples. There are many of them. I'm going to use just the first example. This one uses the library model, the library EMF model. In this case, we have a much wider DSL definition. In the DSL, you can basically define all the customizations for your view in a very compact form. And so you can customize all the things of the JFace components like the label provider, content provider. You can create a new context menu in a very quick and compact way. And as I said, from this specification, we generate lots of Java code for you. Let's see what you get with this simple definition. So in this example, you get a tree with a form. And if you select anything in a tree, you have the form on the right. This form is automatically created by Parsley by inspecting the meta model of the EMF model. We have also support for validation. So if your meta model has some constraints, we analyze these constraints, and in case we put an error marker. And we also have what is called data binding. So if you modify anything here in the form, the model is automatically updated, okay, and vice versa. So if the model is updated from somewhere else, the form is automatically reflected. We have context menu. If you double click, you have a dialog. So you get all these things for free with Parsley. And well, I can also show you that a cool thing is that you can debug the DSL. So if I, let's say, trigger a context menu, then you switch to debugging and you actually debug the DSL, not the generated Java code, okay? So this was just a quick demo. If you want to know more, please go to the talk tomorrow. But this was just to show what we have to test in Parsley, okay? So first of all, there's an Xtext DSL, so we should test the DSL, the compiler, but also the IDE tooling for the compiler. Xtext comes with a nice testing frameworks for testing your DSL. I already gave a talk last year at the Project Quality Day, so I'm going to skip the part on testing the DSL. You can have a look at the talk, or if you're more interested, there's an entire chapter on testing Xtext in my book. So how we started to test Parsley. We started to work on Parsley 3 years ago, I guess. 4 years. So at the very beginning, we were testing everything with SWTBot, okay? And that was okay. We were able to test basically all the parts of Parsley. But the problem is that if you use a functional testing framework like SWTBot, you know that it takes a lot of time to write a test case because you have to prepare all the workbench. And most of all, it takes a lot of time to execute that test. Something similar has already been said in the first talk this morning, okay? So we try to improve our testing approach, and of course the first thing is splitting the core and the UI. But we already did that in the very primordial implementation of Parsley. We did that as much as we could because in the end most of the Parsley important parts are based on the UI, okay? So we try to avoid SWTBot and manually write plugin JUnit tests, but probably, we saw that we saved some time in executing the test, but in the end, all these problems are not a fault of SWTBot, okay? The problem with these tests is the time it takes to start Eclipse to do the testing. And most of all, SWTBot provides a nice API for writing functional tests. So doing things manually would make things worse, okay? So let's take an example we want to test. You saw that Parsley creates a form with controls based on the type of the object you want to represent. So given an EMF object and one of its features, one of its fields, Parsley automatically creates a for control based on the type of the feature. So if you have a Boolean field, we want to create a checkbox. If you have a string, then we want to create a text representation. If you have a reference, we want to create a combo menu, and so on and so forth, okay? And we want to test these things. And we want to test all the combinations for all the possible types. And this form control factory also set up automatically the data binding. So the idea is that we want to make sure that if we create a control in the form and we set the data binding, then if we change the value in the control, the model must be updated, and vice versa. So we have to test all these things for the form control factory. And we used to test that with SWTBot, but we actually can do better. To test these scenarios, you actually don't need a running Eclipse, okay? To test the form control factory and the EMF data binding, all you need is a J-phase control, is a model, is a display, and this data binding realm. But you don't need a running Eclipse. So what we did, we actually took inspiration from this nice blog post from Frank Apple, and we created a JUnit rule for display. So this JUnit rule creates a display and a shell that you can use as parent in your control. And we also added to this JUnit rule some utility methods. For instance, a method that flashes the pending events. So if your code uses a synchronous operation on the display, you have to make sure to flash all the pending events, even because you're not running in the UI thread. So we have this JUnit rule. We need a realm. Actually, this is documented in the Eclipse wiki, so it's easy to create a testing realm for data binding. It's not easy to find that in the wiki, but it's there. We also wrote some utility methods to make tests easier to write. So a method to execute something in the UI thread, because in the end, if you want to check things on a control, you have to do that in the UI thread. So we have a utility method for that. We have some assertion on controls. So we have a method assert checkbox that, given a control, it checks that the control is actually a button, a checkbox, and that the checkbox is checked or unchecked according to our expectation. Again, we have to do this check in the UI thread. And we have other methods like that for labels, for text fields, for combo box. So once we have these methods in place, it's easy to write JUnit tests. We actually write JUnit tests using Xtend. Is anyone familiar with Xtend already? Okay. For those who are not familiar, Xtend is a language implemented with Xtext. It's a kind of better Java with less syntactic noise. So it's more readable. It has type inference, so you don't have to write types if they can be inferred. There are extension methods. In the end, everything is less verbose. And there was a nice talk 2 years ago at the Project Quality Day given by Boris. So if you want to have a look. Even if you don't know Xtend, it should be really easy to read the tests. For instance, this is the test case that, given an object and a Boolean field of the object, invokes the factory. So the factory creates the control. And I check that the returned control is actually a checkbox, which is not checked. Then I try to change the field of the object. And once I set the field, I verify that now the checkbox is checked. And that's all we have to write to check the behavior of the form control factory for a Boolean feature. If the feature is a Boolean but is read-only, we also check that the checkbox is not enabled. And we have other tests for string features, for references, for combinations, for all the combinations of the possible types in an EMF model. So we managed to write tests in a very compact form, but most of all, we can test these JUnit tests as a plain JUnit test. So we don't need to run the Eclipse. And the idea is that for each Parsley core UI class, we have a separate test case, which again is a plain JUnit test case that covers 100% most of the time. So these tests are much easier to write than SWTBot tests, but the important thing is that they are amazingly fast to run. So to run the whole test suite for the core UI Parsley components, which is around 600 tests, it only takes less than 15 seconds, okay? With SWTBot, it requires minutes, many minutes. Well, yeah, sometimes. So in this way, we have an easy way to write tests and most of all, a very fast way to write tests. By the way, if you run these in a continuous integration server, you still need SWT as a library, okay? So you still need a frame buffer. Even if you don't show the display, you still need a frame buffer. Another example, in Parsley we create trees for representing objects, and we create automatically the tree with our content provider and with our label provider. And when the model changes, we want to make sure that the tree is updated and vice versa, okay? So how can we test this without running Eclipse? Well, we create a string representation of the tree and we compare the expected representation with the actual representation with the expected one. Again, with Xtend, it's easy to write these tests because Xtend has multi-line template strings. So in this case, I create a tree viewer with Parsley. I set the model with a container and 2 elements, and I make sure that the tree is represented as I expected. Then I change the model by adding an element, and I make sure that the tree is updated. Note that in this case, I'm using a utility function we have in Parsley, which basically modifies the model and then flashes all the pending events because the tree is updated asynchronously, okay? And again, we can test the tree without running Eclipse, and I think in a very readable way. We also use Mockito. We use mocking for listeners. We have lots of listeners in Parsley. And we also use mocking for events, for mouse events, and most of all for drag and drop events. Because testing drag and drop, even with SWTBot, is not really easy and it's not very reliable. So we mock the drag and drop events and make sure that everything works correctly, again, without running Eclipse. So we created this testing framework for us, but we also release this testing framework as a plugin in our P2 repository. It's still under development. It's kind of documented, so for the moment, use it at your own risk, okay? We probably, in the future, we will make it more reusable also in other projects. But then, of course, we still need functional tests, okay? We need functional tests to actually test parts in Eclipse. So with JUnit, we can test all the viewers, but we need SWTBot to test the view parts. But we have lots of them. Of course, we don't run them continuously, only sometime. And we use SWTBot to test the functionality both for the end user, but also for the developer. So Parsley is a framework for developing things. So we have to test that what is developed works correctly, but also that the developer can use Parsley. So for instance, for the developers, we test that if we create a new project with a wizard selecting a template, then the created project compiles without errors in the workbench. Or if a developer imports a project, then the project is imported correctly and it compiles fine. And we do that with SWTBot. We also have some scenarios with CDO. CDO is the technology that allows you to store an EMF model to a database. So we run some of these tests with with a CDO as a resource provider using an in-memory database, just to make sure that everything works correctly also in CDO. And for continuous integration, of course, we build with Maven Tycho, we use the Eclipse Hudson. We really hope that we switch as soon as possible to Jenkins, because Hudson is not that friendly. We use Gerrit for code review. We also have nightly builds to test Parsley against all the versions of Eclipse, starting from Indigo up to Neon. We use Giacoco for code coverage, find bugs, and most of all, we used Sonarqube. Is anyone familiar with Sonarqube? Okay, it's a tool to analyze the code quality of your project. So, since we have this huge suite of tests that we can run fast and we can write easily, these suite of tests gave us a kind of safety net for experimenting with new features, but also for refactoring the code to reach code quality standards. And by code quality standards, I mean the metrics of Sonarqube, okay? And in the end, nowadays we have 95% of code coverage, which I mean, it's a nice thing. And we have zero technical debt. Again, technical debt in the meaning of Sonarqube. Of course, this is not a guarantee that our project works correctly, but just that we care about keeping code quality and code coverage high, okay? So these are the results of Sonarqube. Most of all, we also have no duplications in the code and zero issues. Okay. Of course, these...
They don't trust you.
By the way, this Sonarqube is hosted at Eclipse, so it's available for everyone. So just go to Sonarqube at Eclipse and search for our project. But I mean, it took us some time. So we started to use Sonarqube 2 years ago, and we had lots of issues. And time by time, day by day, we managed to bring the overall things down. I think, as I said, the important thing was our safety net given by our test suite, which is really fast to run and to write. We also have, we used to have many duplicated lines, and in this case, most of the duplicated lines came from the compiler, from the code generator, okay? So we managed to reduce all these things. In the end, I mean, yeah?
I've got a question. Do you also consider generated code in this analysis? Because we also use Sonarqube, but we say whatever gets generated, let's say from Xtext, with the source gen, and we skip it from the analysis.
Yeah, we skip it as well.
Code, there are findings that we don't want to mingle with our findings.
Yeah, we skip it. We skip it in Sonarqube, but the find bugs analysis in Hudson also analyzes generated code.
Why do you do that? You cannot do anything about it.
Sorry?
Why do you analyze? You cannot do
Well, speaking about extend code generation is almost one-to-one.
Don't talk about extend, because you can change the extend code in order to influence. But for instance, the Xtext code, the EMF code.
No, not that one. I was talking about, sorry.
Extend code is clear that you're
No. I was talking about.
It's just one layer of handwritten.
I was talking about extend code.
Okay.
No, we skipped generated code from Xtext.
Okay.
And I mean, in the end, we also found that having this code quality and code coverage really made much easier to find a bug in Parsley or to create a new feature. Okay, and the other thing is that while fixing all these issues, you also learn how not to make the same mistakes in the future. And we also use JUnit a lot, so I'm quite pedantic in code review, so when Francesco pushes something for review, I usually spot things that Sonarqube wouldn't like. So, okay, what we actually don't do, we currently do not test the wrap version of Parsley. We are starting to use Selenium for that, but it's not straightforward to test a wrap application with Selenium. So we still have to work on that. The nice thing is that wrap really works great. I mean, you take your RCP and you simply switch the target platform to wrap, and you have the web application for free. And it basically works. It just works like your RCP. But we are also planning to do some Selenium testing for the wrap part. That's basically over. Again, if you're curious about Parsley, please attend the talk tomorrow. You will see a much more involved demo. I think you also see wrap in action. Okay. And these are the links. So that's basically all. Please remember to evaluate the session. And if you have questions, yeah?
You mentioned that you use Mockito for simulating mouse clicks and drag drop events.
Mm-hmm.
Usually Mockito is used for passive stuff where the tested code calls something.
Mm-hmm.
I would think it would apply the opposite direction. How did that work?
Well, we actually do both. So sometimes if we need to test drag and drop with a given event, we mock the event as we expect, and we test that everything works. But we also try to do the other way around. So in this case, we spy actually the event, if I remember correctly.
So you create a mock of the event class?
Yeah.
And put them into
And the same for listeners. Or sometimes we mock, sometimes we spy and verify. It depends on the scenario. Yeah.
Which rules that do you use for Sonarqube? Do you adjust it to your needs, or do you really fix all the minor issues? Because sometimes there are some rules that
Concerning Sonarqube hosted at Eclipse, you can't customize much. And we, for instance, there are some minor issues that I personally don't agree, like using spaces instead of tabs. And I prefer to use tabs. And I don't think that breaks my project. And in that case, we adjust the rule in the Maven configuration. And if you have your own Sonarqube, then you can customize everything. The one at Eclipse is not that much customizable. Yeah?
If I understand correctly, then you use the Xtext UI testing framework for mocking all the UI setup parts, basically?
No. I mean, for I didn't talk about Xtext in this presentation. So.
Use some sort of predefined mocking setup? Is that running actual Eclipse?
No. I mean, what I showed before with JUnit is plain JUnit. We don't need to mock Eclipse things at all.
For example, these methods like create tree control or something.
Well, they're just JFace.
Just your code.
And just JFace. So for testing a viewer, which is a JFace viewer, you don't need Eclipse. If you want to test an Eclipse part, then you actually need Eclipse. But for only the viewer, for the tree viewer, for the form, you don't need Eclipse. That's just JFace. And you don't need to mock all these things in JFace. As long as you pass a display, you can still test things on the JFace control. Okay, so thanks.